Hi, everyone. Welcome to our very first in-person event since March 2020. We're so excited to have all of you here, both in the room and for everyone who's tuning in online, for a window into the life of an astrophysicist, a live panel discussion that is part of McGill's Bicentennial Space Week. So I'm your moderator, Carolina Cruz-Vinacha. I'm the coordinator for the McGill Space Institute and also a member of Astro McGill, which is our education and public outreach branch. A few reminders before we start. MSI and Astro McGill are committed to EDI, to equity, diversity, and inclusion, and we can only share Astro awesomeness if everyone feels safe and welcome. So if anyone has any concerns or is feeling uncomfortable, feel free to email the address up here on the screen. And I will ask all of you to please take a moment to become familiar with our code of conduct and the behavior that is expected and is considered unacceptable. So, treat everyone with kindness, respect, and consideration. All communication should be appropriate for a professional audience. If you feel or see something that makes you feel uncomfortable, please contact a volunteer. So we have Garrett up here, and Simon will join us in a second. And if you see any unacceptable behavior, again, feel free to contact either of them. So with that in mind, we're going to go ahead and start. First of all, the way that this is going to work is that this is an interactive panel. So we really want questions from the audience, and we will be taking questions from you live. For those of you joining us in person, we've passed out pen and paper. So if you have a question, just write it down and raise your hand, and one of our volunteers will come and pick it up, and they'll pass it on to us. For those of you joining us on YouTube, feel free to type your questions in the chat, and they will be passed on to me. So now it's time to meet our panelists. So today's panelists are 3 of our MSI graduate students. First off, we have Larry Herman, a PhD student in the Department of Physics at McGill University and the MSI. He works with Professor Cynthia Chang. Prior to pursuing a PhD at McGill, Larry was a test pilot in the US Navy, flying everything from the Gulfstream G100 bizjet to the FA-18 Hornet, the newest P-8A Poseidon patrol planes. That's cool. Here at McGill, Larry uses the aviation experience he gained as a test pilot to develop a drone-mounted system to beam map and calibrate antennas for radio telescopes. The drone work is part of a larger effort where he works on the Albatross project with the ultimate goal of making 21-centimeter measurements to probe the Dark Ages period of the early universe. Next up, we have Maclean Ruble, who is a PhD student in the Department of Physics at McGill and also a member of the South Pole Telescope Collaboration and of MSI. Before becoming a physicist, she was a bartender at a burlesque club. She now works primarily on instrumentation for microwave cosmology, meaning she spends most of her time developing new technology to see very old things. And as a last-minute addition to the panel, we have Nicole Ford, a new MSc student in the Department of Physics at McGill, working with Professor Daryl Haggard to study the most massive objects in the universe, black holes and neutron stars. She uses telescopes to hunt for electromagnetic signatures coming from the mergers of black holes and neutron stars. As an undergrad, Nicole majored in both fine arts and astrophysics, and she's always finding ways to bridge the arts and sciences. So we've prepared a couple of questions for them, and then you can start writing down your own questions. So first off, and I'll go in the same order. So Larry, do you want to tell us a bit about your current research?
Yep, so I work on that Albatross project that you mentioned, which is designed, right now we're just trying to take the first steps and characterize foregrounds and ultimately make 21-centimeter measurements for the Dark Ages, but that's a little ways off. And also for the drone-mounted system, so I work on that. The idea is to fly the drone over one of our radio telescopes and beam map those antennas in real 3D space. And so we are working on getting that up and running, but it's coming along.
What's 21 centimeters?
21 centimeters, just using an emission of neutral hydrogen to look at a period of the universe before there were any stars.
That's cool. Okay, Maclean, same question for you. What's your current research?
So I, as mentioned, I look at very old things, but more specifically, I build technology to do this. So I spend most of my time designing circuits and testing them. And these are for the operation of cryogenic detectors, which is the top left panel on the slide up there, for the South Pole Telescope, which is a microwave telescope. So that's a slightly shorter wavelength type of light than what Larry works with, but not a whole lot. So we use different technology, and we go to different places to build our telescopes, but similar type of instrumentation. The telescope in question, the South Pole Telescope, is at the South Pole, so it's very imaginatively named. It looks very, as far back as we can see into the early universe, at the cosmic microwave background, which is radiation left over from the earliest days of our universe.
Nicole, what about you?
Yeah, so hi everyone. Like Carolina briefly mentioned, I study black holes and neutron stars, which are the most massive objects in the universe, at least that we know of, particularly black holes. They are insanely massive and energetic. We call them high energy astrophysics. That's like the category of research that I'm in. None of the pictures on this slide are actually demonstrating my current research because I'm new. I'm a new master's student. But yeah, I'm now starting to get into research, and so I'm using, in particular, the Canada-France-Hawaii telescope located in Hawaii to look for light coming from when black holes or neutron stars come together and merge and just release a big explosion. So we're trying to look for light coming from that, and we also get this really cool gravitational wave detection when something like that happens. So we're trying to match up gravitational waves and photons so that we can learn more about the sources behind these mergers and just learn more about the high energy physics in general. So yeah.
Awesome. Okay, so our next question is, what got you interested in astrophysics? Or, how did you end up here? Who wants to start? Let's go the other way around. Nicole?
Oh, okay. Absolutely. We can also put my slide back up if
wanna put it back
possible. Yeah, okay. So what got me interested in astrophysics? I've honestly loved it since I was little. My mom was a physicist. She's no longer a physicist, but she was when I was younger. And my dad has been an amateur astronomer. And I think at the very bottom of my slide, it says I grew up in Hawaii. And so this is one of the best places to view the night sky in the world. And so I think I've always been a bit spoiled in terms of being able to just look up at the night sky and just being blown away by how beautiful it is. So that's definitely influenced me. And I've also just always, I think I've always enjoyed the idea of just being able to explore the unknown of the cosmos. I guess if anyone's watched Carl Sagan's stuff, I mean, it's very inspirational. So I grew up with that, and just the idea of being able to try and answer some of these like very big unanswered questions about space, and like black holes are just the most extreme physics we can think of, has been really appealing to me my whole life, really. Yeah, and actually the top right picture is me in Hawaii, in case it wasn't clear. And the bottom left picture, I was also in Hawaii, but that was for, I was doing an art space project for that. So yeah.
That's super cool. That space project looks awesome.
Yeah, thank you. I was painting I think it was a stellar nursery, so the little spot where like stars are born inside gas clouds.
Great. So Maclean, what got you interested in astrophysics?
I feel like my path is slightly less noble than Nicole. I was really into Star Wars as a child, and I took that to the next level in high school when I joined and ran a educational space simulation program for 4 years, and continued my love of sci-fi in general. That sort of blended the sci-fi into actual science, and so I learned a lot about space science through that and science in general, and then pursued that into undergrad and then into grad school finally. So living the dream now.
Nice. Larry, what about you?
Yep. So for me, I did my undergrad and my master's in physics, and I always kind of wanted to come back and finish the rest of the path to PhD. But first, I was a Navy pilot and test pilot for 12 years, and becoming a Navy test pilot, military, flight test is very connected to the space program. All the early astronauts, Gemini, Mercury, Apollo, they were all selected from, Navy and Air Force test pilots. And you still learn a lot about that at test pilot school. You do a couple flights where you fly a small jet called a T-38, and you simulate coming down on the space shuttle, so you have to manage your drag and your glide ratio and all that kind of thing. So it's all very connected to, spacey stuff. So once I was done doing that, I was kind of pushed this direction.
Nice. Okay, so one more question from us for the three of you. So, what is your favorite and least favorite thing about being an astrophysicist? Let's randomize it. Maclean, you want to go first?
Sure. Which first?
Do you want to start with least favorite and then favorite?
Sure. From negative to positive. Least favorite, I guess. I mean, it's pretty good, actually. But I think you have to really like doing this if you do it, because it does eat up a lot of your time. So maybe that's the negative, that it can be pretty all-consuming. And some of that is, there's a positive in there too, because like we're here because we love it. But yeah, you can lose track of other balance in your life easily, for sure. Good thing, well, I mean, that, as said, that is both a good and a bad. I guess other highlights, there are cool travel opportunities, I will say, which is excellent. You get to go to places you wouldn't necessarily go to, especially for observational stuff. Yeah, and spending all your time like asking questions and figuring out how to answer them is a definite plus.
So, a quick follow-up to that, Maclean. What's the coolest place you've traveled?
I mean, obviously the South Pole. It's definitely, hands down, the coolest thing I've done. It's also the coldest thing I've done, but yeah, but not at the South Pole.
Great. So, Larry, same question for you. Favorite and least favorite?
Yeah, I think my favorite would just be kind of the day-to-day. Like, as a PhD researcher, I come into the lab every day and just talk to, other researchers about science stuff that we're doing and how to solve problems with whatever equipment we're working on. And I mean, it's kind of nice to be able to come in and have that environment every day where you're just talking about things that are actually interesting. And for negative, I mean, it's kind of hard to find a negative about being a PhD student at McGill. Sometimes when you're doing field work, the hours get weird, like you'll have to wake up at 3 in the morning to check on an antenna. But even that's not really a negative because it's still a cool experience. So I don't know.
I admire your positivity there. Nicole, what about you?
Least favorite thing for me is more of a general physics thing than like astronomy or astrophysics specifically, but I feel like physics tends to attract people that think they are like almost godlike in terms of their ability to do math and science. And so you kind of have to, you're going to encounter people like that when you go into this field, and you have to just sort of get used to it and I guess figure out how to check your own ego and be humble, and we're just doing math. We're also human beings. So yeah, and also just I think a lot of physicists think they don't need to have social skills because they're just doing math all the time or something like that. So it can be difficult to interact with other physicists sometimes, I'll say. But yeah, the positive, and these guys are wonderful. They have social skills, yay. And in terms of my favorite thing, I guess I've already sort of hinted at it, but I think that the night sky is amazing, and so being able to to put in some controls and tell a telescope to point somewhere in the night sky and then receive light from that telescope and then go and analyze it and learn something about the universe is just super, super exciting. And I'm an observational astronomer, so for someone who does theory, they might have a different reason they love it, but that's for observational astronomy, that's my favorite thing.
Great, thanks. So now we're moving on to questions from the audience. So as we said, if you are in person in the room and you have a question, raise your hand and one of our volunteers will go get it. And if you're online, type it into the YouTube chat. So we've already received a couple of questions. I'm going to start with those and then go to the ones in the room. So our first question, which I think is from the YouTube chat. So related to what we were just talking about, what or who in your life triggered your decision to become an astrophysicist, if there is a particular person or event?
Should we each answer, or do you think maybe?
So the way we're going to do this is you can either each answer or just jump in and answer if you want. Not every person might answer every question, but up to you. So who wants to take this one first?
I guess I can contribute.
Go ahead,
Feel free
Maclean.
to discuss as well. I don't know if I had a particular person or specific moment. As mentioned, I worked as a bartender for a long time before becoming a full-time physicist. So there was definitely a transition from one to the other. I do know when I originally decided to stay in physics was partly being given the opportunity to do so. Working part-time or full-time during undergrad meant that I didn't have the greatest grades and didn't have a lot of hope of getting into grad school, but I managed to convince a former professor of mine to take me on as an undergrad research assistant, which was the first time I realized I might have a chance at staying in the field, which to my surprise made me so happy that I was like, oh, I guess maybe this is what I want to do, and so I'm still here.
Yeah, I have kind of the same sort of answer. It wasn't really one particular person that ever really pushed me towards. Just something I always kind of wanted to do. And so when the opportunity arose, I kind of jumped at it.
Yeah, for me, it was just probably my mom, because she was a physicist when I was growing up, so she always encouraged me to be interested in that.
Nice. Okay, so we have another question from the audience. This is a fun one. So after doing so much research about space, what do you view it as? Is it still a spooky, mysterious void for you, or does it feel more and more familiar? I love that question.
It's very spooky. Even potentially more spooky once you learn more about it.
Honestly, that's true. We have no idea what's up there.
Wait, so the more we study it, the spookier it becomes?
Yes.
Yeah, I mean, nobody knows what's out there. I mean, if we had it all figured out, we wouldn't be here working on it. So.
Yeah, not to mention the whole dark matter and dark energy thing, where 98, is it 98? It's 94%, like large percentage of what is out there, we have no idea. And so, as it turns out, there's a lot more to learn.
I think that's good for all of you, because there's plenty of work to be done. Okay, so do you have a favorite scientist? And if so, who and why?
It would be my advisor, Cynthia Che.
I second that one. Cynthia's amazing.
I feel like now I have to say my advisor. Daryl Haggard is also amazing. I hope anyone who's here can meet her someday, because she's just super inspirational and very down to earth and friendly. And she did a philosophy degree before switching to astrophysics, and I did art as well as physics. So it's just inspirational to see people do disparate fields.
I mean, I'm feeling a little bit of peer pressure here as well. Certainly, my advisor is excellent. I was going to go for the star power route and say Jennifer Doudna, who's the professor in biology who invented the CRISPR-Cas9 technique for that work, but also just in general, her history of intense problem solving through experimentation is very cool. I want to meet her someday.
That sounds pretty cool. I hope you do meet her someday. Maybe she's listening. Okay, so here are a couple questions about the training it takes to become an astrophysicist. So, can you be an astrophysicist without a PhD?
Yeah, sure. I mean, everything is just a process, right? The process of doing astrophysics isn't what we all do different things, and we all say we do astrophysics. I spend most of my time turning screws, honestly. But the most important part, I think, is the asking questions and then trying to find a way to answer them for yourself. And if those questions are related to astrophysics, then you're doing astrophysics when you do that. So anybody can. That's my stance.
Yeah, I don't think any science job as a scientist requires a PhD. I mean, the famous example is Einstein. He was a patent clerk, so.
That's true.
Yeah, I'll just add, I guess the caveat is if you're thinking about doing it in the traditional sense of going and being a professor or something like that, there can, in academia, there can be more pressure to get a PhD in astrophysics in order to continue that academia route. That said, I've also seen a lot of people, especially younger people, doing masters in astronomy or astrophysics, and you can still do quite a lot with that. You can go in computer science or data science. We get a lot of training related to computers and coding just because of our jobs. So, and you can still do astronomy with that training, even if you don't have a full PhD.
Yeah, and that's a good point about going to do other fields. We get a lot of people coming from other fields too. In my lab, we work with several professional engineers, some of which have been engineers for a long time and are just, sort of volunteering their time, and others who have just finished an engineering PhD or an engineering bachelor's or something, and they come in and do astrophysics with us. So there is a mix.
Yeah, so in a similar vein, what jobs can you have as an astrophysicist outside of academia? Because Nicole, I think this picks up on something you just mentioned. So.
I might have already sort of answered that, but there are a lot of different jobs you can have, and I've actually thought about this extensively because I don't want to stay in academia, even though I'm pursuing a graduate degree. So, like I mentioned, you can go into data science. There are places like Google and all of that stuff that are always looking for people trained in coding and data processing, especially big data. Besides that, one path I've been interested in is like going into climate science, because a lot of the physics that we learn in our astrophysics training is also relevant for like modeling the Earth's atmosphere, or even the atmospheres of other planets, all that stuff. So like you could do like planetary science as well, which is sort of like it's connected to astrophysics, but it's also its own thing. And if you're interested in like combining other fields, I've also thought a lot about like science visualization and communication. Those are important skills that you learn as an astrophysicist, like how to convey your data. So you could go that route, especially if you have any like art or graphic design training. And you could do things like go into space law. There's a lot of different fields that can be combined with astronomy, really.
I would echo what you said about data science. So before I started a PhD in physics, I was like, what kind of jobs are out there for a PhD in physics? And I typed physics PhD into a bunch of the job search websites, and there's pages and pages and pages of people looking for data science people. So
Yeah, we have a lot of data.
Great. Okay, so we have another one. I like this one. How has astrophysics and answering the big questions affected your personal philosophy towards life in general? That's a big
And
question.
we're supposed to have an answer to that, like on the spot?
I'll let you think about that one. So this one's related, but maybe a little bit easier to answer. So it says, many astronomers report a cognitive shift when observing/researching. Has this been the case for you?
I think at least for me, I tend to get kind of focused on the individual stuff I'm working on that day and trying to get working, and oftentimes don't think about the larger implications of stuff like that. I'm just trying to get through what I'm trying to get through at the time. So I don't know. I think I haven't spent a lot of time thinking about the huge picture stuff like that.
I agree. That's also like, I don't exactly know what cognitive shift means for this, but like, yeah, as a grad student especially, you're always being given like so much work all the time that it's really easy to just get lost in like building stuff or doing coding, any of that. The times where I actually have the easiest like take a step back and like appreciate what we're doing is when I do outreach and communication, like with you guys, because then I'm not just like in my little hole of research for the moment, but I'm actually like thinking about what I'm doing from a larger perspective.
I think I don't know if I experienced like a particular shift or moment when I realized that I thought about things differently, or differently than I used to, but a sort of slow creeping process over the course of an undergrad and then master's degree had been that the more physics I studied, and I'm not going to say the better I got at it, but just the more of it that I saw and the more time I spent doing it, I realized that I like thinking about the way the world works, and now I have a increasingly solid framework to do so, and that has been soothing in a meditative sort of way, but also just a nice, a pleasing way, I suppose, to have shifted my way of thinking into.
Okay, so I'm going to let you think about the big one for a few more minutes. In the meantime, there's a question for Nicole directly. But anyone else can answer if you have. I think other people might have answers to this question. So how do you merge arts and sciences?
Oh my gosh, my favorite question. If you want, you can put my slide up again just so people can look at the thing I painted. So I am always trying to find ways to do it, like I said in my bio. The way that is easiest for me usually is to find science visualization opportunities. So if people are directly trying to convey a science concept, I will happily offer to create an illustration for them of that concept so that people can learn about it in a visual way rather than just hearing words describing something. So that's like the easiest way. But honestly, I don't know. I feel like art just comes into my research like all the time. I'm always like sketching out my ideas and just trying to make it a visual process. And even like when I process data and I'm like trying to plot it in a particular way, just the graphic design of how I do that is really like influenced by my art background. So yeah, it really just comes in all the time.
I think I might take advantage of the fact that I know you and I know your work to ask you a bit of a follow-up question. Do you want to tell people about the aliens project you had to do?
Oh yeah.
Because I think that's super cool.
Yeah, so when I was an undergrad and I was a double major in art and astrophysics, I was in an art class where we had an assignment to create 100 objects. Anything, just had to be 100 things, and we had a week to do it. And so that's a lot of stuff to produce for one person. And so the project I ended up doing was I came up with 100 different aliens and 100 different planets for them to live on. And I made trading cards for the planets, and I built all the aliens out of clay. And they're all like pretty tiny. They're just like the size of a coin because I only had a week. But yeah, so just another, yeah, I definitely did a lot of art projects in school that were also space themed.
Do you want to talk about how that one has influenced outreach?
Yeah, we just had, I don't know if anyone was here earlier today, but we've been doing Space Week events, and so we had a booth today where we let kids also do this exact same project. They came up with aliens and what kind of planets they'd live on, and they came up with some crazy stuff. Someone had like a alien that lives in a swamp and only communicates with antennas. So it's really fantastic to see people get creative.
Yeah, if anyone wants, we're going to post those on social media. There are a couple up now, but we will be posting all of them if anyone wants to see them. They're very cool. Does anyone else have thoughts about arts and science?
I was going to give Nicole another shout out for another project I know you've done that I thought that I just learned about and thought was really cool. And as I guess it's somewhat artsy, but also just a interesting way to represent things in a less visual representation of physics. Like we spend a lot of time looking at computer screens, which requires us to see what's on the computer screen, and I could imagine would be challenging to do this kind of work if you couldn't use visual cues of any kind. And so this very cool thing that Nicole's done is to 3D print luminosity maps of interesting astrophysical regions, like the center of our galaxy, where they're embossed higher or lower depending on how bright that region is, and so you can touch it and you can feel the texture and the shape of the galaxy and see where the stars are and where the gas is. And you should probably explain it better than I can.
No, that was a great explanation. Carolina also is the one that helped find these objects for us to print. But yeah, it's a really great tool, and hopefully maybe we can post some pictures of those on social media as well.
Yeah, so this is a project called Tactile Universe, because I do want to shout out the person who actually made it. You can follow him on Twitter. No, it's super cool. I mean, but yeah, there's so many good ones, and they're all open access. So we will post a link to that in the description of the video, so if anyone wants to see.
That's even better than I thought. I didn't realize it was an open source thing. Very cool.
Yeah, there's many different galaxies you can print out. If anyone has access to 3D printers, it's a fun option.
We had been looking for an excuse to print them, and this is the perfect one. So now we have some of them. Okay, so switching gears a little bit to something more fun. Well, not that this isn't fun. What kinds of pop culture depictions of space frustrated you with their inaccuracies? Do any of them get it right? I know this is a big thing with astrophysicists, so.
Yes, I think is the answer to both of those questions. Often portraying things in many aspects of pop culture as they are, like of life or anything just as it truly is as we experience it, isn't always that interesting. And so a lot of pop culture things will take liberties in one direction or another, but often I find there's like, especially in more modern sci-fi, I guess, there's like, they'll get specific things really right. I think the first example that comes to mind is this like one really short scene in The Expanse, which in general I think is pretty good for the science portrayal of things, but there's this one great scene where one of the characters is in an environment that has a reduced gravity, and there is a bird outside his window, and the bird sort of like I'm going to try to do this with the microphone, like flaps and sort of like gently things, and then like flaps again, and it's just a little sparrow. And so when you see that on Earth, like they'd have to really be flapping fast in order to stay in one position, and there it's just like one slow motion, and it's like just and it's like maybe a 2-second shot, and then it doesn't pay any more attention to it. But I thought that was like subtle and good.
I mean, you could have no end of examples of movies that have stupid depictions of science in it. I mean, there's famous examples like, I don't know, Armageddon, or like, where
my God.
like there's an
Sharknado.
entire like 2-hour YouTube video going over problems with that movie. Or so I don't. But I mean, at the same time, they're trying to appeal to a wide audience, and it's just kind of a fun blockbuster. So.
I was going to say one example that I think was done really well is if anyone's seen Interstellar, they actually hired a consultant to help them convey science accurately. It was Kip Thorne, and they depicted this huge black hole called Gargantua in the movie, and the way they depicted it is actually like super realistic with like the way light is bent around it due to the effects of general relativity. So that was also very visual, very beautiful to look at. But they did a very good, accurate job of that.
I remember there was a lot of press around that depiction of the black hole.
Yeah.
Yeah. I might want to add one there too. This is Prometheus. But just to see what people's faces are when you say that. Okay.
We have to give the Alien franchise a little bit of credit because they are the ones that came up with the in space, no one can hear you scream, which is true.
Yep.
I know Alien is fine. It's Prometheus I have a problem with. We have a question that is directed at Maclean, but I think Larry can answer as well. So I want to hear from both of you on this one because you're both instrumentalists. So does the job of an astrophysicist also include designing prototypes, like using your creativity to design instruments and to develop newer technology? I know this is what both of you do. So.
Yes. So for one of the fun things about what all of us do is that we're trying to answer questions that obviously haven't been answered, but also sometimes that we need to build or new things in order to answer. So this is a fun thing right now in astronomy because as technology moves forward, it opens up new doors to new things we can do with it, which then lets us, see new things or detect new gravitational waves or other signatures. And so I spend all my time thinking of ways to build new instruments to enable the science that we as a collaboration want to do.
Yeah, I think. I don't know if I turned my microphone off.
No, did you press a button? I did. We were supposed to press a button.
I didn't mean to.
Do you want mine?
Yeah. Okay. Yeah, I think pretty much any experiment or project that you jump onto is going to require you to make or build something new. It's just part of the nature of doing science work. An example for what I'm personally involved in is the drone work that we're doing. It's only just recently that it was possible to build these kind of things and fly them for just regular sort of people without being a big company. So stuff like that. Yeah, I think building stuff is part of the process.
I guess adding to that too, that the prototyping stage, like we think about, designing a whole new experiment from scratch, but you have to have a few trial runs at this. Like first you design it on paper, and then you design it in code, and then you design a very small version of it to test because that's cheaper, but also you don't want to invest many years of your time on something and then find out, that you've gotten the wrong screw size or something. So physically building smaller versions of everything that we do is a very fun and rewarding part of the job.
Nicole, do you have anything to add or not really?
Yeah, I don't really build things. I guess for an observational astronomer, we have to propose why our science deserves to be on used by certain telescopes, and sometimes we have to say we actually don't have any telescopes that can do the thing we want to do. So we are consulted when they're designing new telescopes, for example, just to make sure that the telescopes do what scientists need them to do.
Cool. So following up a bit on that, since you mentioned observation, what kind of observations do you do? That can be for all of you.
Okay, I'll go first, and then maybe you guys can also. So I usually observe in the optical part of the spectrum, so that's stuff that we can see with our eyes. But I mean, really, telescope observations span the whole electromagnetic spectrum. So we could be doing like ultraviolet observations, and we learn something different depending on what wavelength range we're actually looking at. So yeah, I'm looking forward to observing in multiple parts of the spectrum going forward. And I guess, yeah, I think I already previously talked a bit that I observe black hole and neutron star mergers. So that's what I'm looking for. I'm looking for the explosions that come from those big things merging together. Yeah.
Does anyone else want to jump in?
For the experiments that I work on, it's really long wavelength radio observations, like targeting down below 30 megahertz or so. So really, the observations that that my research stuff makes is really radio observations.
I think on the my observing on the day-to-day anyway tends to be when testing new prototypes for our upcoming telescope is a lot of like simplified schematics of, has this detector that I'm building a circuit to get the signals out of seen light, has this other one, can I put them together to know that there's an object that's shining on them? So it's a slimmed down version perhaps of what you guys do.
Good. So we've already talked a bit about like building, a bit about observing. So we have a question here. What do you spend the most time on? So trying to get funding, experimentation, writing papers, anything else? Classes?
Programming? Honestly, 95% of my time is Python.
I spend a lot of time physically building things, whether it's stuff for the Albatross experiment, antennas, back-end electronics, things like that, or the drone. A lot of time I'm physically working on building something.
I'm also in the programming camp. It's like, yeah, 95% of my time is just coding in Python, or thinking about how to code things in Python.
So this is kind of going in the same vein. Could you take us through a typical day in the lab or in the field? I think you're all in the lab or at the computer in Nicole's case. So who wants to go first?
I could go. So it depends on like my graduate experience so far has been mostly going to classes, and the class that actually Maclean and I just took is radiative processes, which is modeling how light gets emitted in astrophysical contexts and how it like moves through material in space. We're very important for understanding astrophysics. So yeah, as like an early grad student, a lot of your time is just spent on taking classes and getting like fundamental training so that you can do research well later on. But if I'm not working on homework or preparing for an exam, I'm usually with my laptop and coding to process data that we've collected from telescopes, or coding to prepare for data that's going to be collected from telescopes, or maybe writing something because we still have to write stuff even though we're like mainly doing physics and data processing. We do, like I think Carolina said, sometimes have to apply for grants or write papers about the work we've done. So that's also a thing. Yeah.
So my life revolves sort of around a semi, like 2 or 3 weekly cycle to do with the testing of the cryogenic systems that I work on. So I guess that's probably more interesting to talk about than a day-to-day, because depending on where I am in that cryogenic cycle, what I'm doing during the day varies a lot. So the cryogenic systems we use to cool things down take several days to get cold because they get extremely cold, down to a fraction of a degree above absolute zero. And that whole process of just the cooling takes 2 to 3 days, and so then there's the warming up. It takes a long time too. You want to do testing while you're cold, and then once you are warm is when you can actually install stuff and make changes to your system. So if I'm on a warm day, for example, or on a warm week, do you have the picture of the the slag? There's a so that's the system that is labeled lab work. That's when it's open. There's a view like up inside this giant can, which you see me standing next to in another one of those pictures for scale. And so I spend my time turning screws, installing objects in there, attaching things with wires, building stuff with a soldering iron. And then I close it all up and take all the air out of it and cool it way down. So those days are spent actually turning more screws and pushing buttons. And then I wait, and then it's cold, and I take data and I do Python for like many days. And then it warms back up and it repeats.
Can you do an interpretation of the noise that the cryo?
Oh yeah, so the main the main cooling element in there is called a pulse tube cooler, which pulses helium to cool the main element in the fridge down to 4 Kelvin or minus 269 Celsius, and it has this 1.4 times per second precisely. It does a little like pew 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 pew, which is constant in the background of the lab. You like kind of dance sometimes.
It's also been on the background of a lot of Zoom calls.
Yeah. It's actually helpful because I just have to unmute and then people know I want to speak. And so it's very useful.
So I would echo what Nicole said, where if I'm taking a class that semester, then that can easily take up a lot of time. But otherwise, it's some combination of being in the lab, lately working mostly on our drone work and kind of alternating between that and group meetings, whether they're in person or in Zoom. And the drone in particular has taken up a lot of time recently because, as you can imagine, the airspace in a place like Montreal is pretty complicated and not super easy for the aviation governing body to let you fly around in kind of when you want to. But there is a way. It's just time consuming, so I've been working on that lately.
So we have another question that I think this is a fun one. So can you tell us about an astrophysics task that almost seems false? False. Like something that is so weird that people wouldn't believe you actually have to do it. I think that's the intention behind the question.
I mean, I feel like I do a fair number of weird things. Okay, so great one. Also has good names of equipment. So I do a lot of hands-on work with telescopes. Most of my time is spent up in the north doing like small cryogenic testing. When you are on site at many telescopes that move specifically, one of your duties is to keep them in like physical maintenance, like the structure needs to be maintained, they rust, they wear down, that kind of thing. And so you have to grease them. And so there are, for the South Pole telescope in particular, which is the one I'm familiar with greasing, there are 2 main grease elements. There is large gears that you sort of, hold your breath and turn it off first and then stop it moving and reach your arm way in there with the grease and try to, in these giant gears, which is terrifying. The other thing that needs greasing is when you take a grease gun, which is like a big caulking gun, but that is extremely slippery, and you put on the shirt that you care the least about, and you climb up inside the telescope, and you put the grease gun on the grease nipple, and you inject the grease into the telescope, and it's very personal.
I don't like the words you used.
These are real terms. These are real terms. I apologize.
Did you say grease nipple?
I did. Not with a D on the end, just grease.
Just grease.
Yeah.
Okay.
I will say that reminds me, I've been inside so big telescopes have like a thing that supports them so they can rotate around, and you can sometimes climb inside that thing that supports them. And at least the one that I've been inside of is just filled with dead moths. It's like a whole layer just along the entire bottom, because basically they all fall in through the top of the telescope and then they're just stuck. So I don't recommend climbing inside the thing that supports big telescopes.
Thankfully, we don't have that problem at the South Pole. There are no moths.
We have a question about what it's like to be a grad student. So are there any older grad students doing their master's or their PhD in their 40s at McGill? This is from someone who's thinking of pursuing an astrophysics degree but worries that they'll stick out because of their age.
So I am old. I'm not 40, I'm 38, but I'm probably one of the older students here in the Astro department.
Yeah, I think I can think of a couple of grad students who are sort of maybe older than you as well. It definitely, the age group is clustered younger. I'm a couple years older than average, I guess. And I don't know, I guess it can be odd at first when you don't know anybody and you just feel like, oh, I'm behind. But on the other hand, everybody's there because we love what we're doing, and the community, at least I have not felt that different from my peers.
Oh, no, not at all. I haven't felt different than any other student. And like you said, everyone's here because we want to be here. And it hasn't been a problem. It's the only thing, and I wouldn't even call it a problem, that was a little bit difficult was going back into a classroom after being out of one for like over 12 years. But
Oh my God, undergrad was rough, honestly, but like definitely worth it. If it's something you're interested in, I think you should definitely at any time.
no, it's not like a mountain that you can't climb. So
Okay, so if you could change one thing about the field, what would it be?
Make it more accessible, please. I mean, it's, I think it's a struggle for a lot of STEM fields that typically have been like white male dominated, but physics has especially had problems with this. And so just finding ways to make the field more accessible is, I think, a huge important task that is starting to be addressed now just by like having more role models that look different, and so people feel more inspired to stay in the field, or telling people that they actually can do it instead of just like, oh, you're a woman, why are you trying to do math, or something like that. I've heard all of that stuff before. And even just making it more accessible for people that like might not be able to come into a classroom in the typical way, or just converting your learning materials for physics like labs to be easier to do from home, things like that. For sure would be very, very useful. And especially for doing science, having more brains involved is always helpful for coming up with new ideas. But even without that motivation, we should always just want to let anyone do physics or science. There should be no obstacles to doing that.
Yeah, definitely seconded, especially on the sort of people coming from all sorts of different backgrounds. I think it's a valuable contribution. I'm probably biased because I'm like, oh, well, I used to have a different job before I was in physics, but I'm happy that I had that other job. However, having that other job made it pretty hard to get into physics because, in terms just like practically speaking, I'm physically able in every sense of the term, but having slightly lower grades or being busy working another job meant that I was ineligible for funding. I was ineligible for most research opportunities, and like there's just no. Can be a hard thing to get around, and I would imagine we might miss out on a lot of motivated people who are willing to participate for many reasons, like physical accessibility, financial accessibility, cultural inaccessibility, all that.
I think a lot of people would say they'd change it by providing more funding for more projects.
Those are all really good answers. We have a couple of questions that are similar, so I'm going to try to ask them together. So what are your thoughts on the rising wave of science deniers? Does it impact the way you do research or the way you communicate your science?
Is it a rising wave, or is it just that it is maybe more vocal and has captured more attention because people in prominence have voiced it more?
It might be the prominence of science denial.
Yeah, prominence. Okay. I guess I don't know whether I think that there are more people who think that way. Certainly, there are louder people who think that way. I don't know. I like a good argument, but I'd rather have a good discussion. And so, if I'm happy to have differing opinions from somebody on something and to talk to them at length. If somebody wants to be very closed-minded, I guess myself included, that just doesn't lead to a good discussion. So I guess that's a roundabout way of saying that discussion is good, but closed-mindedness in any sense is not good.
Agreed.
Yeah, I don't think I've seen too much of it in the sorts of things that I look at. I mean, I don't think a lot of people are denying radio waves or things like that. But so thankfully, I think at least for the stuff that I look at, it's been kind of insulated from that.
I guess like the second part of the question there is what I'm maybe going to push all of you a bit on it. Does it change the way that you communicate your science or the way you explain your science to people, knowing that there might be some pushback in that sense?
I'm definitely motivated to try and make it accessible because I don't want someone to like be closed-minded about a physics concept because they just feel like they don't understand it, so therefore it's like not true or something like that. So I'm definitely very motivated to try and communicate things in a way that is going to be understandable for someone that isn't had a bunch of background in this. And I guess for stuff that's not physics, generally I just try to be patient with people and treat them as human beings, but sometimes that's hard.
Yeah, I'll agree. That was one thing actually that was really fun about my past job, especially when I was getting towards the end of my undergraduate degree, is bartending and talking to a lot of people of a huge variety of backgrounds and almost exclusively non-physicists. It was very fun to talk about physics in that context, or just talk about science in general and hear what people thought and what people's views were, what people learned, remembered from school or were interested in, and get that, just that dialogue going back and forth. And I certainly learned a lot of things that I hadn't heard of before, and I gained a great appreciation for starting, or just talking about something that is a shared interest between two people regardless, and then sort of going into science from there. That's a cool thing with physics, because you really, no matter what you're talking about, if it is somewhat science-y, there is a cool physics thing that is related to it, and that's fun. I'm such a nerd. I hear myself, wow, I really like physics, I guess. I'm great at parties, I swear.
So we have another question that has been asked a couple of times. So why is thaumaturgy, I hope I'm saying that correctly, which is in parentheses, fortune telling, quantum healing, etc., and astrology, for example, still prevalent in the age of science? If that's something any of you want to jump in and
I
tackle.
have not heard of quantum healing before.
I don't know what that is either. But astrology we've heard. Definitely.
Yeah, I mean, astrology's been around for a really long time. And if you go back in history, most astronomers were also astrologers. That was, we studied the heavens for, well, I will call them heaven. We studied the sky in order to predict what was going on in our day-to-day lives. And for most of recorded history, that has been in the form of, in placing characters or personas into what we saw up there and trying to use that to understand our day-to-day life, because that's how we relate to the world. We are, social creatures, and we react to other people. We try to predict what they're going to do, and so why not do the same thing with the sky? I don't have a whole lot of problem with astrology. If you want to be interested in it, that's fine. It's not particularly something I'm interested in pursuing, but yeah.
Yeah, I know astronomers will frequently cringe when someone says, "Oh, you do astrology instead of astronomy." But yeah, I also agree. I really don't have much of a problem with it. I feel like there's room for both. They're just different interpretations of the sky, I guess, and life.
Yeah, I think the only aspect of some of quantum healing sounds, I guess I don't know what it is, but it does sound, anytime somebody just puts quantum in front of a word, it's usually gimmicky, and I do have a problem with when people use pseudoscience to sell stuff to people. That's not cool.
Yeah, monetizing, not as good.
That's not cool.
Yeah.
Good. So we're coming to almost 8 o'clock, so I'm mindful of the time. And there are lots of questions. We're not going to be able to get to all of them. However, I have the final 3 questions that I'm going to ask. So first of all, I think this might generate this might give you space to talk a bit more. So in your opinion, which objects should we research more?
Yeah, all the things.
All of them?
All the things deserve more research. I mean, even our own Earth deserves more research, because, NASA, for example, has huge programs just for studying our atmosphere. Very hard to understand. But yeah, looking outside of Earth, of course, black holes need to be studied more. What the heck?
No bias
What's going
there,
on in there? We don't know. We have an image of the outer perimeter of a black hole, but it's very mysterious. So, however we can continue to study those and get more, testing general relativity, all of that stuff would be very, very helpful.
It's kind of hard to give a single answer, especially it's hard to nail it down to astrophysics and stuff too, when there's good answers from medicine and things like that, and lots of things that need to be studied and looked at deeper. So I don't know, it's hard to come up with a good answer to the question.
Yeah, I mean, we could all just say the thing that we study, which would be, I mean, clearly, hopefully we all think that, or else it might be time to find a new group to work in. Yeah, I agree with black holes. I don't particularly study them myself, but you got onto using them as a probe for larger physical frameworks like general relativity. And so here's where I plug my field, where we look at the very early part of the universe. We can look at how general relativity and quantum mechanics may or may not play nicely together. And that's a big goal in modern physics today.
Yeah, unifying the forces, all of that.
Yeah, so you've all said that there are so many things to research and probably not enough time. So What are some ways that amateur enthusiasts of astronomy can contribute to research?
Lots of ways, yeah, and increasingly more ways. Pandemic's been really good for getting like online stuff going, where you can participate in all sorts of projects. I know there are a few like open source. The one I think of right now is called Galaxy Zoo, which has actually been going on for a little while, where it's training machine learning algorithms to identify galaxy types, and the public participates by saying like, yes, this is this type of galaxy. You're helping to train this important scientific tool. There's lots of things like that.
Yeah, you can always go out and buy a telescope if you're, there's lots of different price ranges for telescopes, so you can get small ones for relatively inexpensive, and always like look up at the night sky with them. I think there are also programs where you can like monitor specific objects with your telescopes and then like report your data. So stuff like that. And if you want to do like more researchy stuff, you can always look around for professors who are doing research that interests you and just reach out and see if there's any stuff they need help with that you could do to just get more experience with astronomy.
Yeah, my mind went to the same place that you said, where just buy an amateur telescope and just kind of keep general interest going in the field.
Or build one. I've recently learned that you can build a radio telescope with a coffee tin, and a wire, and a way to digitize a signal, which is great. And you can use that for, well, admittedly, just with the coffee tin, you'll be able to see when the sun is up. But if you put your coffee tin on a satellite TV dish, you can see pulsars, which are cool. You can contribute to pulsar timing efforts. I've discovered a huge, vibrant online community of people who do this. And you can discover dark matter for yourself by mapping the rotation curve of the Milky Way, all with the coffee tin and like a small dish. It's great.
That's awesome. I want to do that.
Nicole, do you want to talk a bit about, we were displaying a citizen science project at the booth this week, right? Do you want to talk a bit about that?
Yeah, so there's like a whole bunch of citizen science projects are online, and usually they just involve astronomy researchers putting their data up online for the collective general public to help identify and classify things. And so we have one that we were using at our booth that is identifying fast radio bursts, which are these mysterious pulses of radio signal that we don't really know where they come from, but we have to sift through a lot of data of like human-made noise because we emit a lot in the radio before we find actual signals. So regular people that haven't been trained can still do really, really, really good visual data processing. Humans are just really good at identifying patterns in data, so very helpful to have that.
Yeah, we'll make sure to share the links to some of these in the description of the video and on our social media. So we're at time. So to end on a lighter note, and I think I might know the answer to this question, so 2 days ago, former astronauts were on this very stage. Would you like to be one now?
Well, sure.
Yeah, definitely.
I am probably a no, because I have a fear of flying. So I like to be on the ground looking up at the sky. I don't want to be in the sky, at least not until we have ships like Star Trek.
I agree with that.
Yeah. Which are a long ways off, I think.
Great. So thank you all so much for the great answers. This was so much fun. And thank you all for coming and for joining us both in person and virtually. Stay tuned for more events. We'll be trying to hold some more public lectures over the summer. But for now, please join me in thanking our panelists for this great panel. Thank you so much and have a good night.
Oh, observing.
Oh, right. We will be doing observing outside at at about 8:15. So if you head over to Lower Field, we will have some telescopes up so you can look at the night sky. Yeah. Thank you.
It's a clear night.
Yeah, it's a clear night. We lucked out on the weather, which we never do.